chargedevs.com. CATL plans to mass-produce Naxtra sodium-ion EV battery packs by the end of 2025. Some expect sodium, which is cheaper and more readily available than such materials as lithium, cobalt, and nickel, to power the next generation of EV battery technology. Now, Chinese battery giant contemporary Amperex Technology, CATL, says it expects to bring its Naxtra sodium-ion EV battery pack into mass production by the end of 2025. Sodium-ion battery technology is no longer a research achievement in laboratories. Gao Huan, Chief Technology Official for EV businesses at CATL, told reporters, "We have achieved a breakthrough not only in terms of energy storage, density, and cost, but also found a new key to environmental protection." Gao said the new battery delivers specific energy of 175 kilowatt per kilogram, nearly on par with the 185 watt-hour per kilogram achieved by the lithium iron phosphate LFP batteries currently used in most Chinese-made EVs. The Naxtra battery product line includes two categories: the Naxtra Passenger's EV battery, which CATL says offer a 500-kilometer range and can achieve over 10,000 cycles, and the Naxtra 24-volt heavy-duty truck integrated start-stop battery. Both versions are capable of performing across the full temperature range from -40 degrees to +70 degrees. CATL first unveiled its sodium-ion battery technology in 2021. In 2023, the company said Chery Automobile had become the first customer for its sodium-ion batteries. LFP 이제 양산하는데 중소듐 배터리 출시 예고에 한국 설왕설래. 드릴로 뚫고 톱으로 자르고 BYD 이어 CATL 배터리 쇼크. 리튬 대신 나트륨을 사용하는 나트륨 이온 배터리를 올해 하반기 중에 양산하겠다고 발표했다. Your next EV could be powered by salt. Why sodium-ion batteries are the next big thing? What if the very salt you use to season your food is the same that powers your gadgets? Yes, it seems like lithium's time in the sun has ended as CATL, the behemoth that manufactures 40% of the world's lithium batteries, plans on pivoting half its future business to sodium-ion technology. When the company that built an empire on lithium starts looking elsewhere, you know something big is happening. Every person owns roughly a minimum of 5 objects that are powered by lithium-ion batteries. They're in everything from your phone to your video doorbell to your earbuds to even your electric car. Lithium-based batteries literally power the world today, but there's a fundamental problem with them. They're unstable, fairly scarce, and difficult to acquire without completely ravaging the environment. That's why the world's largest battery maker is looking at the next best alternative, the same stuff you line your margarita glasses with. That's right, salt, or as scientists call it, sodium chloride. From table, salt to battery powerhouse. Sodium sits one row below lithium on the periodic table, the overlooked middle child to lithium's golden boy status. Both elements share a crucial trait: they readily surrender electrons, making them perfect battery materials. But sodium atoms are here. But sodium's atoms are pudgier and behavior than their lithium counterparts, creating the technology's HL's, low energy density. Current sodium-ion batteries pack roughly 160 to 200 watt-hour per kilogram compared to lithium 300 watt-hour per kilogram. When it comes to building EVs, the disadvantages stack up pretty quickly, given how heavy existing EV batteries are. Swapping out lithium for sodium would make these batteries nearly twice as heavy, severely impacting the car's overall weight and therefore its range. Yet, despite this handicap, sodium is increasingly finding adoption in battery tech. The reason becomes obvious when you look beyond the spec sheet. The Earth's ocean hold approximately 180 billion tons of sodium, a supply so vast it makes abundance seem like an understatement. Lithium, meanwhile, exists primarily in remote, short flats and hard rock deposits, concentrated in geopolitically complex regions like the Lithium Triangle of South America and conflict-prone areas in Africa. Extracting lithium demands intense water usage in often drought-stricken regions, creating environmental flashpoints and community tensions. Sodium, by contrast, can be sourced from seawater or common soil deposits through simpler, less resource-intensive processes. The environmental footprint difference is stark. Cost also plays a significant role in this pivot. Salt is cheap, dirt cheap, actually cheaper than dirt, while lithium prices have ridden a roller coaster that threaten to derail EV adoption. Sodium remains stable and abundant. BYD, Tesla's most formidable global competitor. Projects sodium batteries could eventually undercut the lithium cost by 30 to 70%. For an industry will pennies per kilowatt hour determine market winners. That's not just an advantage, it's potentially game set match. The gray salt rush of 2025. CATL isn't merely pontificating about sodium's theoretical potential. They've already commercialized it. Their Vivo battery pack combines lithium and sodium cells in hybrid system for long-range EVs, threading the needle between sodium cost advantages and lithium's energy density. Their second-generation sodium battery, launching later this year, promises energy density exceeding 200 watt-hour per kilogram, while still trailing lithium. This represents a remarkable leap from the first generation 160 watt-hour per kilogram. The gap is closing faster than many expected. BYD, meanwhile, is making an even whole play. Their sodium-ion gigafactory under construction will churn out 30 gigawatt-hour of batteries annually when fully operational in 2027, enough to power roughly 600,000 electric vehicles. For perspective, that's more than the entire UK electric vehicle market in 2023. The sodium rush extends beyond the Chinese giants. Zhejiang Energy recently fired up a 4 gigawatt-hour production line with plans to quintuple capacity. Across the Pacific, American startup Naxtra Energy is building a 24 gigawatt-hour facility in North Carolina after establishing a beachhead factory in Michigan. Sub-Zero superstar, why winter loves sodium? Beyond cost and sustainability, sodium-ion batteries offer performance advantages that anyone who's driven an EV Minnesota will appreciate. Exceptional cold water resilience. Lithium batteries are a frigid temperature. Lithium batteries and frigid temperatures mix about as well as cats and bathtubs. Below minus 20 degree, lithium ions struggle to intercalate properly into the anode, instead plating onto the surface. This lithium plating reduces capacity, damages the battery, and in extreme cases creates safety hazards. Sodium ions, with their larger size and different chemical properties, resist this plating effect. CATL claims its second-generation sodium batteries function reliably down to minus 40 degrees, the point where Fahrenheit and Celsius coverage in conventional lithium batteries essentially give up. For drivable in northern climates, this is a minor technical distinction. It's the difference between reaching your destination and calling a tow truck during winter months. For fleet operators, it means consistent range regardless of season. Sodium batteries also demonstrate superior thermal stability at the other end of the thermometer. They're less prone to thermal runaway, the very equivalent of chain reaction that can lead to fires. For grid storage installation in hot, fire-prone regions like Australia or California, this safety profile could prove decisive. TAQ team, the MIT breakthrough changing the game. While commercial sodium batteries advance rapidly, researchers are attacking sodium's energy density limitation from another angle. Scientists at MIT's Lab have developed an organic cathode material called TAQ that could fundamentally change the sodium battery equation. Traditional cathodes rely on metals like cobalt and nickel that are scarce, expensive, and environmentally problematic to extract. TAQ replaces this with carbon, hydrogen, oxygen, and nitrogen. elements so abundant they form the backbone of life itself. The researchers claim performance rivaling cobalt-based cathode at one-third the cost. What makes this development particularly intriguing is its industrial backing. The initial research was funded by Lamborghini, not exactly a company known for investing in technologies without performance potential. When a manufacturer of 200 mph supercars takes interest in sodium batteries, it suggests the technology's limitation might be more temporary than fundamental. When salt gets in the wound, challenges ahead. Despite the momentum, sodium-ion technology faces significant headwinds. The dramatic collapse of lithium prices, down 70% over the past 3 years due to production increases, has temporarily weakened the economic case for alternatives. The battery industry is not notorious cyclical, and sodium's cost advantage look less compelling when the lithium is cheap. Sodium battery manufacturers also remain too small to benefit from economies of scale, creating a classic chicken and egg dilemma. They need the volume to drive down the cost, but struggle to achieve volume without competitive costs. This challenge claimed a victim in Swedish manufacturer Northvolt, which unveiled a promising sodium battery in 2023 before filing for Chapter 11 bankruptcy protection. The technology also faces an entrenched interest. The lithium supply chain represents trillions in investment, from mines to processing facilities to battery factories. This industrial momentum creates resistance to change, even when the alternative offers compelling advantages. The sodium stratification, finding each chemistry's sweet spot. The sodium stratification, finding each chemistry's sweet spot. The most likely future is in a wholesale replacement of lithium by strategic deployment of sodium in applications where its strengths matter most and its weaknesses least. Grid-scale energy storage represents sodium's most promising beachhead. When batteries are stationary, energy density becomes secondary to cost, safety, and longevity, all areas where sodium shines. As solar and wind deployment accelerates, the demand for affordable storage will explode, creating a natural market for sodium technology. For electric vehicles, a segmented approach seems probable. Budget models and urban delivery vehicles could adopt sodium batteries first, leveraging their lower cost and excellent cold weather performance without requiring the energy density of long-range vehicles. Premium cars might retain lithium for years longer, or adopt hybrid systems like CATL's Freeboard and combine both chemistries. Budget models and urban delivery vehicles could adopt sodium batteries first. This market segmentation parallels what we've seen with lithium batteries themselves. Different formulation NMC, LFP, and CA have found niches based on their particular strength rather than a single chemistry dominating all applications. Worth its salt, The future of sodium power. Battery technology evolved through persistent iteration rather than dramatic breakthroughs. Sodium-ion batteries exemplify this pattern. They don't render lithium obsolete but complement it by addressing specific weaknesses in our current energy storage system. And the world's largest battery manufacturers bet billions on technology. I pay attention. CATL and BYD have built empires by recognizing inflection point before they become obvious. Their aggressive sodium expansion suggests they see a major shift coming, one that could reshape the energy storage landscape over the next decade. For consumers, this transition promises more affordable electric vehicles that perform better in cold climates. For a grid operator, it offers cheaper, safer energy storage solution. For the planet, it represents a more sustainable path forward, reducing dependence on problematic mining operations and making clean energy more accessible globally. This sodium revolution won't happen overnight. Technological inertia, existing investments, and ongoing improvements to lithium batteries ensure a gradual transition. But the trajectory seems increasingly clear. That humble white crystals seasoning your food is poised to power our electrified future. Next time you reach for the salt shaker, consider that you're handling what might become the lifeblood of tomorrow's energy systems. In a world obsessed with exotic materials and complex solutions, there's something beautifully elegant about pairing the future with one of Earth's most common elements.